Hello, my name is Shalwa. In this video we will discuss about the forecast. First of all, forecasts are always wrong. Don't trust, check this out. Computer in the future may weigh no more than 1.5 ton. It's the popular mechanic magazine. Another there is no reason anyone would want a computer in their home. President of Digital Equipment Corporation in 1977. But forecast is very useful. It provides some valuable insights who better analyze data is better in the business. For example, black line is a real demand and red line is a forecast. At right here, linear chart forecast more or less is a fit to real demand, but at the left chart after 40 week does not work. Forecast actually is a straight line. This table is divided two sections, at the train section and the test section. At the train section it's possible to calculate how to accuracy is our forecast model, and after this we develop for the test section actual forecast. There's a lot of case when the train section the accuracy is high, the test section it does not work. It means future always outsample. Let's discuss about the criteria for forecast evaluation. There's the two indicator, validation and implementation. First, there's a comparison with the well accepted models. On the picture you can see a lot of models exist and you should to compare each other which is the fit. Normally if there is many models we can compare with each other and choose the perfect one. For example, naive model, ARIMA forecasting, artificial neural network, or simply exponential smoothing models. We should compare to each other and choose the relevant one. Another is use of ex-ante validations. Ex-ante we mean there is many theories. If you provide data and know it likely to this particular model it works better. When a feature is outsample, what can we do? It is at a training section and estimate its errors. In a trend seasonality or level parameters, use of reasonable sample of forecasts. Mostly forecasting histories, the good one is 40 samples data sequence to train, but it depends on a data. For example, if we have a monthly sales, we minimum need 1 year or 2 year base data for training, and after we choose the forecast model. At the implementation section, first is a convergence. Actually relate to artificial neural network in a machine learning or deep learning models, where the very difficult to convergence each other, but as a exponential models or ARIMA models, it's very easy to compare each other and make a convergence. Another is a generalization. So generalization relate to the accuracy of the focused models. For example, we have the accuracy indicators. This is MAPE, MAD and MSE. We will discuss more precisely on about that. Last point is stability. We mentioned the training sample. We divided the data into two sections, training sample and the test sample. There is no few cases when at the training stage accuracy indicators, which I said MAPE, MAD and MSE is well, but the at testing stage is devastating. It's depend on the stability. While we jump on another sections, I want to go through by detail errors. See on a table we have the week sequences, sales, 3 weeks depending moving average model. What I mean, for example, here is a calculated by previous 3 weeks values moving average value, and etc. we calculate it. Imagine we passed this period and now we testing how accuracy was our moving average forecast model. First we calculate the errors, simply just minus sales to forecast, actuals minus forecast. After absolute calculation each one and make sum them, and after the average of these sums, mean square error, it's calculated, it's a squares of absolute values, and after this absolute values calculated average. And at last, which is very useful and I will use in my models, this is the mean absolute percentage errors. We calculated to weight it with each sales, which I calculated individually, and after we calculated the weighted of this average. I mean my falseness was a 8.6%. This actually the mathematical equations, and this the definition, but in Excel it's more easy to calculate, compare each other. Next topic is a good forecast depends on how well we understand the forecast that contribute to it. While we start the forecasting process, it should to perform data on line chart and try to assess its seasonality, trend and levels. In general, handle the seasonality is difficult. May for this task help us a qualitative information on about the data. Seasonality can be confusing. A season is a fixed length of a time that contains the full repetition. This is the crucial. We need to calculate the full repetition in time length. You may think in your data repeats daily because the peak of sales is at 2 p.m. every day. But if the weekend has a different behavior, for example at Sunday there is no peak, then your season is really a week, not a day. In general, it is advisable to cut a line chart by pre-estimated time periods and view if it fit, as on a picture you see. On a matrix you see maybe seasonality has an additive or multiplicative pattern, also as a trend. You should understand the data whenever you see at a first. Next is how much data is available. In this section you should not concentrate the volume or sequence of data. Also there is a very crucial the qualitative information and whether the focus can affect the thing we are trying to forecast. I mean, tomorrow if announced the exchange rate will increase, also this forecast has influence and the impact on future. Okay, at the next section we will go through the models in an Excel. First is a knife forecast, total average, moving average, weighting moving average, simply explanation, smoothing, Holts trend, Holt-winter's multiplicative trend, and Holt-winter's additive models. So first the knife forecast, and let's see on a table. We have this kind of data, which is the sales data and period. We divide it in two sections, testing and training. We should compare each other, mean absolute percentage errors. And let's start by knife forecast. Knife forecast is very simple. It takes the previous period's value, and whenever you jump in the testing section, I will take at the last period and repeat. 7% is total MAPE, and on the graph looks like this. You see at the testing period very pure forecast. Next is a total average. The mathematical equation looks like this, but in practice on a table very easy to calculate. Okay, let's check in. We took the previous period. At the third period I calculate previous all periods average, and whenever you increasing, it's aggregating its previous periods average. At testing period, finish my data and starting the forecast and continue this total average amount at the testing period. Mean absolute percentage error, it's pretty high because the data. So next is a moving average, mixture of knife and total average, and let's see on a tape. This equation looks like this. For a moving average, we calculated the average function, and let's take the 2 period. In the formula m was a 2, and let's continue till the test section. Okay, here's a finished our sequence. Let's for next. And also error is possible to calculate. Accuracy is better than just the total average, and also on the graph looks like this. Next is a weight moving average, and here's a bit tricky, and let's see in a practice. Weighted moving average, it looks like just the moving average. For if moving average we took the previous 2 periods average, it means we took 50 to 50. Now we can to add power of each values. For example, the most previous period has 0.7 and the before the previous period, let's 0.3. So calculation, it looks like this. Total accuracy, it's decrease, which is the good, but it does not still finish this model. We have the possibility to use in Excel the solver. Okay, solver works like this. Here the accuracy, which is the object, required to get this minimum, but the variables 0.7 and 0.3 change this way. But this 2 value has its constraints. Let's add the constraint. Okay, and let's make solve. Okay, and we optimized these values for receive the most optimized error. On the graph, it looks like this kind of outline. The next section is simply exponential smooth. And now we have this kind of additional smoothing parameter alpha. Pretty interesting. Let's see on the table. Simply exponential smooth calculate like this. Take for alpha 0.2, indicator 0.2, and continue this formula on table. First initial value took this way. Take alpha, fix, multiply y sub t minus 1 this way, plus open parenthesis mean minus for this period. Change the formula. Let's use the last period of training section, fix this, and continue smoothing. Also, let's calculate the errors. Also, here is a possible to recur by solver to optimize the alpha. Shape looks like this, and let's continue. Next is the Holts trend. We have level and trend, alpha and beta, and let's see on a table. Practically, Holts trend should develop 3 columns. First is a level, which they relate to alpha, smooth parameter. Second is the trend, which relate to beta, and after actual forecast with the additional to trends subtract to level. Okay, at the initial moment calculate this way. At the test section, we shoot the horizon. We pass the Holts trend, we use the alpha and beta, and the next section we will use Holt-Winter's multiplicative method and use the solver after all. Okay, let's see on the table. When you start the Holt-Winter's model, first task is to estimate the seasonality. Now let's see here, we have the 1 year and we estimate that the curve has a yearly seasonality. You see this hills is the seasons, 1 by 1 year. Okay, let's write here this kind of formula. This is my initial data in seasonality. First initial level is current sales divided its relevant seasonality. Trend should calculate it the levels minus open parenthesis actual sales divided its relevant seasonality. Trend calculation at initial moment start to seasonality calculation. We took this formula. Now we calculate the level, which is the alpha needed here. The trend possible to calculate beta multiplicate. And the forecast, we should use this formula, levels plus trend and multiplicate, because here's the multiplicative method, and at its relevant seasonality. Now this is the second month. Yes. Oh, I missed something. Here's a need a minus. Now we spread this formula. We should attribute its horizon. Focused section should change a bit the formula. So last level should fasten plus open parenthesis its relevant horizon and multiplicate 86. But I should fix the last trend. We calculate the whole period of forecast and let's calculate the errors. This is the very good accuracy of MAPE, and let's see on the table. Yes, very good outline, but it's still not finished. We should optimize of my smooth parameters, and I will use solver. As you see, we finish our forecast models, which is the possibility calculate in Excel, very easy and cheap. Another method is possible to make a forecast in Python or in RStudio, but this is very easy and very cheap to calculate our forecast. Good estimation of parameters, seasons, trends, and these kinds. It's possible to receive this kind of good trend, good forecast for the next period. That was our multiplicative methods. I will not explain the additive method because very similar, and multiplicative method is the better, of course. And thank you for watching, and bye for now.